Okay, so we covered a linear search in the last video, and this search is going to focus on a binary search. The very first thing that has to happen in a binary search is that we have to sort the list. So we've done sorting, we've done 4 sort algorithms, we've done insertion sort, selection sort, bubble sort, and quick sort. So we know how they work. You could use any of those on this to sort this list. But what we're going to do, or what we probably should do in this, just to make it as easy as possible, is if we say that this is my list, and I will do proper code for this now in a minute. I can go my list dot sort and call the sort function. And if I just print the list, then I will get a sorted list, which is going to be 17. I have to do this slowly now so I don't make a mistake. 24, 31, 45, 50, 63, 85, 96. So I end up with my sorted list that looks like that. So the very first thing in a binary search we're ever going to do is we're going to sort out the values so that they are in order. The easiest way to do that is to call the sort function that Python has, but we've also looked at other ways to sort lists as well. Okay, so now I have my sorted list here typed, so you're able to read it a little bit better, hopefully. And what I have to do is, what I'm looking to do then is use the binary search to sort this. The binary search, effectively what it's doing each time is it's going to cut the amount the list has to be searched in half. So what we have to keep track of is 3 main things. So let me just get my colors up here. We have to keep track of the start of the list. We have to keep track of the end of the list, and we have to keep track of what I'm going to call the half interval, because that's what it calls it in the book. I'll tell you how we decide on these now in a minute. So this is the start of the list, so we have to keep track of the index of the start of the list. We have to keep track of the index at the end of the list, index at end, and we have to keep track of the half interval index. So the half interval index is basically the halfway point in the list. But in our list example here, the halfway is not a direct halfway because the middle of the list is 45 and 50 together because it's not an uneven number. So the way we can do that is to calculate that half interval index is we can take the value of the last or at the end from the first, and if we do a division, a floor division by 2, that gives us a whole number as a result, so it doesn't give us any decimal places, so it basically rounds it down regardless. Well, it doesn't round it down, it floors it. So if it was, say for example, if the result of that was say 45.78, it would just give you the whole number part of it. And that's how we calculate but we'll come to that in a few minutes. That's how we calculate the half index. So the other thing that we need in this is we are going to need obviously some key value like we had in the other one. So we have to have something that we are looking for. If I set the key to 17 just to try to work with that. So the first index is going to be equal to the 0 index. Just let me change the colors here. So this is going to be equal to the 0 index, and this is going to be the length of the list minus 1. So 0, 1, 2, 3, 5, 6, 7. And in this case, the half interval is going to be the first minus the last minus the first floor, 2. So the last is 7 minus the first, which is 0. 7 minus 0 is equal to 7. And divide that by 2, but floor 2, 4, 6 is 3.5. But actually we just floored with 3, so 0, 1, 2, 3. So that's how I've calculated my floor index, or my half interval index. Then what we do is in this algorithm, so now we have our list. We have our start index, we have our last index, and we have our half interval index. And what we do is we check the value in the half interval index. So we have a look at the value here, and we check is the value at the half interval is that equal to the key. So the key in this case is, let me put back on my purple, is 17, and the half interval is 45. So they are not equal to each other. So when they are not equal to each other, it iterates through again. So what it does in this case for the iteration, it's different to anything we've done before, is it does a check to see if the key is less than or greater than the half interval. If the key is less than the half interval, which it is in this case, it resets the list to the lower half of the list, and it searches that using a binary search again. So let me say that again. If the key is less than the half interval, which it is in this case, it takes the lower half of the list. So it leaves the start list where it is, but it changes the index at the end to the half interval minus 1. So it moves it to the half interval, which is here, minus 1. And then it gets the half interval of that new list, which in this case is going to be 24. It checks to see is 24 equal to the key. It's not. It checks to see if the key is less than or greater than. You can say less than. You can just do 1. Less than the index. And it's not. So it moves and it searches, or it sets the start of the list, or it sets the end of the list 1 less than the half interval. So it sets the end of the list here. Oh, now I've ruined it. Hang on. Try that again. So I have my start of my list here. I have my end of my list here. And my half interval can only go here as well, because that's the only thing that's left in the list. So it checks if the half interval is equal to the key. In this case it is, and it returns the position of the key. It's hard to see in a small search like this the way it works. So I'm going to run through it one more time. I'm going to rub all this off, and I'm just going to step through it one more time all over again. Okay, we are going to do that all over again. You probably could have just rewound the video, but anyway, we have our unsorted list here. This is our unsorted list, and it's called my list. And this is the unsorted values. This is my unsorted values, okay? And we're going to do a thing called the binary search. The binary search is different to the linear search. The linear search may potentially have to search every element in the list to find what it's looking for. But on average, the binary searches twice the speed because it takes half the time on average. That's not every time, that's on average. And the reason for that is because it splits the list in half every time, every iteration of the search, which we're going to see now in a second. So the very first thing we have to do is, for binary search, we have to sort the list. So my list dot sort is using the sort function in the Python library. You could actually take that list and run your insertion sort, your selection sort, your quick sort, or your bubble sort on this to sort it either. But there's an inbuilt function in Python, so for ease and speed, we can just sort it. And when we run that sort on it, we end up with this sorted list that we have here. And it's on this sorted list that we are going to actually do, or if I can get this to stay still, we are going to do our actual sort. So in this sort algorithm, we have to keep track of 3 different things, okay? The first thing is we have to keep track of the index at the start of the list. So this is my index at start of list. I have to keep track of my index at the end of the list. So I'm going to do that in black. Index at end of list. And then I have to keep track of what's known as a half interval. I'm calling it a half interval. It's kind of like the midpoint. So index at half interval. because the terminology when you look this up or Google it is going to say half interval. So what is that? It's effectively the midpoint of the list that you're searching. How do we find the midpoint of the list that we're searching? There's a number of ways we can do that, but the simplest way, and the way we're going to look at doing it, is we are going to take the value of the last or end of list. Oops, end of list. Hang on now. I just don't, we won't mix up the colors. So I'm going to take the end of list minus the start of list, and we are going to floor divide that by 2. So floor divide that by 2, let's go through it. If the end of the list here is 0, 1, 2, 3, 4, 5, 6, 7, and the start of the list is 0, we've 7 minus 0, floor divide by 2. 7 minus 0 is 7, floor divide by 2. So 7 floor divide by 2 is equal to 2463.5. But what happens in a floor one is it takes just the whole number. So it doesn't round up or round down, it just takes the whole number. So the half interval in this case is going to be the value at the index 3, 0, 1, 2, 3 here. And once we have that, then we can actually dig into the actual binary searching part of it. So what happens is in the binary search, oh, we need something else. We need, if we're going to search, we need to know what we're searching for. So we have to set a key value like we did in the linear search. So we're going to set it to the same thing as 17. It makes this a little bit messy to draw out, but we'll do it anyway. So we have our index at the start of the list, which is 0. We have our index at the end of the list, which is 7. We have our half interval index, which is 3. And we have our index at the start of the list, which is 0. And what we do is we are going to do a check to see if the key equals the half interval value. So we're going to do a check to see if the key is equal to the half interval, sorry, my writing is terrible, value. So we do a check to see if that's the case. If so if they equal each other, so the half interval value is 45, so we're going to say, is the half interval value 45? Is that equal to the key 17? In this case, it's not, false. If it was true, then we would return that index value and print out where we'd found the key that we're looking for. If the key is less than the half interval value, we assign the value of the half interval index minus 1 to the variable last. But if it's greater than, we assign the half interval value plus 1 to the first. In this case, 45 is greater than 17, so we are going to do the half interval index plus 1 to the first. Yes, that doesn't make sense because 17 is less than 45. It's not the other way around. So it's if the key is less than the half interval index, which it is in this case, 17 is less than 45, we are going to assign the value of the half interval index minus 1. So what we do is the end of it, end of the list, moves to the half interval index minus 1, which is here. And now we have a new list that we are searching. The new list that we are searching is this list here, which I'm doing in purple because it's kind of hard to see. So in effect, we have disregarded this whole part of the list. And we go through again and we find the half interval. We can do the maths we did over here, but I know it has to be 24. And then I'm going, is 24 equal to 17? It's not. 17 is less than 24. So now we have a new set of lists to search, and that new set of lists is just this value here. So we set the beginning, the end, and the half interval. It's quite blocked here to 17. The yellow to 17, and then 17 is equal to 17 is true, and we return that index value. I'm rushing because I'm nearly at 15 minutes and the video will stop. But hopefully that makes a little bit of sense to you. And what I'd like you to do is try to write out the code for this yourselves now before you go to the next video.